Hello there guys, how's it going? Mike coming back at you here with another video from Calculus 1. In the previous video, we looked at Rolle's theorem, and we used Rolle's theorem to prove the big theorem that relies on both differentiability and continuity, and that theorem is the mean value theorem. We looked at the statement of the mean value theorem, and we went through the proof of it using Rolle's theorem. In this video, we're going to go through some sample problems to see how we solve the type of problem that you typically see associated with the mean value theorem. So what these types of problems look like is you'll be given a function f of x, you'll be given some interval, and you'll be asked to find the value of c that satisfies the conclusion of the mean value theorem for the function over the given interval. Just as a quick recap, what the mean value theorem says is if your function is continuous on the closed and bounded interval a comma b, and if your function is differentiable on that same open interval, then there exists a c value between a and b such that f prime of c is equal to f of b minus f of a divided by b minus a. Or also what this is saying is that the instantaneous rate of change of your function at the c value is equal to the average rate of change of your function over the interval. So we kick it off with our first question here. F of x is equal to the square root of x. We're going to find the value of c that satisfies the conclusion of the mean value theorem for this function on the interval 1, 16 if it applies. So first thing you always have to do in these kinds of problems is you have to check to make sure that the hypotheses of the mean value theorem are satisfied. Is your function continuous on on the given closed and bounded interval? And is your function differentiable on the open interval as well? Well, our function in this case is the square root of x. The square root of x is defined for all numbers greater than or equal to 0. It's also continuous and differentiable for all numbers greater than or equal to 0. So that means that on this interval, both hypotheses hold. So we can use the mean value theorem here. Now we need to find that c value. And what we're going to do in these problems, what we're going to do is we're going to calculate the two parts of our equation that are in the conclusion of the mean value theorem. We're going to calculate these guys separately, and then we're going to set those things equal to each other, and we're going to solve for c. So first we're going to solve for the average rate of change. We're going to solve for the f of b minus f of a all over b minus a here. Well, looking at your given interval, the first number that's written is a. The second letter the second number, that's given is b. So making those substitutions, f of b minus f of a all over b minus a is f of 16 minus f of 1 all over 16 minus 1. And plug these values in, take the difference, and simplify. You come out with 1/5. So that's the right-hand side of our conclusion of our theorem. Now we're going to calculate the left-hand side. We need f prime of x. Really straightforward to find that the derivative of f is 1 over 2 times the square root of x. This means that f prime of c, we're just taking c and we're substituting that in for x. So f prime of c is going to be 1 over 2 times the square root of c. And it's these two results that we are then going to set equal to each other, and we're going to use these to solve for c. So that's exactly what we did in our next step here. Set those two things equal to each other. I can cross multiply here to give me 2 times the square root of c is equal to 5. I need to get that c all by itself, so I'm going to divide both sides by 2. And then lastly, square both sides to get rid of that square root, and we get 25/4, which as a decimal is 6.25. And note that this c value does fall between 1 and 16, just as the theorem says that it should. So this is just our first problem here, using the problem associated with the mean value theorem. Next example, f of x. This time we have a rational function. It's 5x divided by 2x minus 3. Find the value of c that satisfies the conclusion of the mean value theorem for f of x on the interval -1, 2 if it applies. So again, we're checking our hypotheses here. Is the function continuous for every x value in this closed and bounded interval? Is the function differentiable for every x value in the open interval, -1, 2? Well, this is a rational function. The function is not defined at any x values for which the bottom is equal to 0. So set the bottom equal to 0 and solve for x. We get a positive 3/2 or 1.5. Well, last time I checked, 1.5 does fall between -1 and 2. So f of x is not defined at 3/2 and thus not continuous at 3/2. Therefore, it's not continuous on the entire interval, and therefore we cannot apply the mean value theorem to this problem because our hypotheses are not met. Our function is not continuous at every x value in the closed and bounded interval, -1, 2. So this is just one case of why you have to be sure to check that the hypotheses of your theorem hold. And third and final one here, let f of x equal e to the x. Find the value of c that satisfies the conclusion of the mean value theorem for f of x on the interval 0, 2 if it applies. So I want you guys to try to figure this one out on your own. So pause the video here, check to see if the hypotheses are satisfied. If they are, continue on through and find the value of c that satisfies the mean value theorem's conclusion using the same process that we used in our first sample problem. So pause it now, and then once you've figured it out, press play, and we will go back through this problem. Okay, so let's see what we came up with when we tried to solve this question. First up, are the hypotheses for the mean value theorem satisfied? Well, we have the interval 0, 2. This is a closed and bounded interval, so that's good. Our function is e to the x. E to the x is continuous and differentiable for all real numbers. So the function is continuous on the closed and bounded interval, and it's also differentiable on the open interval as well. So the hypotheses are satisfied. We're going to calculate the average rate of change next. F of b minus f of a, all over b minus a. Once again, first number listed is a, second number listed is b. So f of 2 minus f of 0, all over 2 minus 0. F of 2 is e squared, f of 0 is 1, so we get e squared minus 1 all over 2. We're now going to calculate the left-hand side of the conclusion of the mean value theorem. We need to find f prime of x. Well, because it's e to the x, it's the nicest guy that we have out there. We just get e to the x. So f prime is e to the x, which means f prime of c is just e raised to the power c. We then set these two results equal to each other. So we get e to the power c is equal to e squared minus 1 all over 2. We want to get that c all by itself on the left-hand side, pardon me. What we have right now is something that is in exponential form. If we convert this to logarithmic form, we will then come up with our c value. And when you convert this into logarithmic form, or if you just take the natural log of both sides, both things get you to the same end value, you find that c is equal to the natural log of e squared minus 1 all over 2. And if you were asked to round to 4 decimal places, what you would get is 1.1614. And again, if you check back at the statement of our problem, this value of c does fall strictly between 0 and 2. It does fall within the interval that we had. So these are just a few sample problems about how to solve mean value theorem questions. You're given a function, you're given some interval, you're asked to find the value of c that will satisfy the conclusion of the mean value theorem, if you can even do that. So first check your hypotheses, make sure all the hypotheses are satisfied. Once you've checked that they are satisfied, calculate the average rate of change over your interval, then find f prime of c. Take those two results from the two previous steps, set those equal to each other, and then solve for c. In the next video, we are going to move on to the other big topic that we begin to get into in Calculus 1, and we're going to carry on with it more in Calculus 2, which is antiderivatives or integrals. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, guys, take it easy.